Hey everyone, so I recorded this last night and phantom power on my microphone actually has two RS-485 connections, and they run Modbus over that. The first one they have, which we are not going to use, it's to talk to other Sol-Arks or other inverters. So if you want to run two in parallel, you want two 15Ks for example, or two 8Ks, they need to communicate with each other. So that's what this bus is here. That's what that's for. Now they do have a additional RS-485 for monitoring, and I'm like, oh, that's the key. And I did find a document online that shows that what registers you can get, although it was for the 12K. But I'm thinking that it's probably the same, and maybe they added some additional registers to look at. The only problem is this RJ45 connector right here. It's kind of multiplexed. Well, it's not multiplexed. They're using some of the pins for the CAN bus. Sol-Ark uses a CAN bus for its battery closed loop system. But it also provides RS-485 for just monitoring purposes only. I don't see anything where you can control the inverter remotely, what they call relays in Modbus. But you can set register values too. But it looks like it's like read-only, which I'm okay with. And if that's the case, then we'll just do with read-only for now, because they do have another place on the Sol-Ark on the side that you plug in their Wi-Fi module to, and it has an Ethernet port on it, which is, I use the Ethernet port, but I'd have to reverse engineer that to get all the communication that's using. So I don't feel like spending all that time doing that, and I still use that interface for the phone app and the web app as well. But like I said in my last video, I'm not that impressed with their my Sol-Ark app, and it doesn't update in real time, and it takes like 5 minutes. You may have to pay money to have it do once a minute, and I don't want that. I want to know in real time within a second. So that's what the Modbus is for. So that's what this whole project is, this interface. I'm just giving you a little bit of background information. So the other interesting thing is they do have a rapid shutdown interface, and I am using the rapid shutdown input from my Tigo, but I'm not using the power source here. It's 12 volts and it's just not used. So I'm like, well, I could use that to power my remote device. It's 100 milliamps, which a little bit limited. You can't run a Raspberry Pi off of that. There are plenty of display and ARM processor solutions that you can buy bundled together sometimes that would probably have a much lower current use. And that's the whole point of using ARM, right? It's just that the full Raspberry Pi, I know, is, that thing generates some heat. 100 milliamps is not going to cut it. But it'd be very close, and I don't want to damage my inverter. So here's their pinout of that RJ45 connector, and you can see the center two wires, it's a pair actually, is for the CAN bus. And I do definitely use this for my closed loop battery operation with the Sol-Ark, so that the charge cycle is handled automatically and there's feedback to the inverter. And basically the battery management system for my EG4 setup is controlling the charge cycle. Otherwise I'd be in open loop mode, which you can do with the Sol-Ark. It'll take any battery, but open loop mode is a little bit tricky because you got to monitor the voltages and the current. But in closed loop mode, it's a lot more automated. The battery system says, hey, charge me or discharge me. It can also do its own leveling, and I've done that, and it's worked quite well. Now they have a communications hub for my system because EG4 uses Modbus. They don't have a CAN bus. They may on some of their newer stuff, but for my EG4s, the life power racks, and I have 6 of them, you can chain them together with Modbus. So I had to add a communications hub. This is the communications hub that I use, and actually it's quite nice because it's a modest cost, but I can go through this screen and go up and down, and I can actually look at all the batteries and all the individual battery packs inside of them, and see what their status is. And I actually had a problem with one of my batteries. One of the, I don't want to call them cells, we call them packs, right? They call them packs on here. One of the packs had a low voltage, so I just took screenshots of that. And EG4 has a 10-year warranty on this particular battery that I have, the Life Powers. And when I showed them all the information and the individual, what was going on with the individual packs, they honored the warranty and even paid for shipping. And I shipped that battery, that rack back. It's quite heavy, but I got it out and I shipped it back, and they sent me another one, and it's been working great. So hat tip to EG4 for that. This comm hub was quite instrumental in looking at what's going on with the batteries. It's just a Modbus embedded system is what it is, but you know, it works pretty good. And you can't see here, but there's actually a CAN bus output that connects back to the Sol-Ark, providing the Sol-Ark with a battery management system altogether, and it's consolidating all the battery packs for you, and it works pretty good. It has some micro SD features that you can your PV panel arrays, there's 3 that you can plug into this, are right here. And we're going to be focusing on this connector here, and then the rapid shutdown area here, and using the 12 volt supply that they give you. You know, so what is RS-485 anyway? If you remember the RS-232 ports that computers used to have, you don't see them that much anymore. But you know, your traditional modem connection was an over RS-232, which typically go up to 115 kilobaud at short distances. It's not as immune to noise as you would like it to be, but it's good for short distances. So they're using RS-485, which uses what's called a differential pair. If you're not familiar with it, isolated pair going into an op amp, and you get what's called common mode rejection. So any signal that passes through, or a noise passes through both wires here, will cancel out because one side's positive and one's negative, and noise going through, it's a common mode, which means it affects both. They will be out of phase, they cancel out at the inputs of all these devices, so you get noise immunity. You don't get that with RS-232. The key thing with RS-485 is it's half duplex. You do save on wire because it's only 2 wires. One device can transmit while the others receive, so it's a common bus. So it works well when you have a master-slave configuration like Modbus, where the master sends out a command to an address. One of the devices will respond back. The bus is quiet and it listens for a response. It's half duplex because you can only go one way at a time. For what we're going to do, it's probably more than enough. I know it's used in HVAC and some other things with programmable logic controllers, where you have a bus and you have multiple sensors, and you're collecting data from those sensors, and it's kind of like a round robin thing. And your master has software, and that's the thing about Modbus. It's all software driven. There is nothing in a hardware stack that does any mitigation for you for error correction. And it'll go round robin. So let's say this is your master here, and these are all your slaves. It would just go like this and around, and you could have hundreds of these theoretically. The thing is with that bus, and you want to use twisted pair to get that tight noise reduction, you have to put a line termination on each end. It goes to impedance matching and having reflections on the line, which is a common issue with any transmission line. That's what this is. But what's great about RS-485 is if you're at a lower data rate and you have the right termination on here, you could probably go 1,000 or 2,000 feet. Kind of perfect for a home environment, which I'm doing, because I'm only going to go to my thermostat, which I'm looking now from here is roughly 40 feet maybe. Now CAN bus uses a similar topology that RS-485 uses. It uses pairs. The difference is their error correction and their lower level checking and address resolution is done on hardware. So you're taking a huge load off of the processor itself. So since RJ45 is the connector they use, we can use Ethernet cabling, either Cat5e or Cat6, and you get the twisted pairs built in. if it's good enough for Ethernet, it's going to be certainly good enough for this. It's such a lower data rate. And I have tons of it, and I even stripped some back to show you the 4 pairs, and we're only going to need 2 of those pairs for our project. So they sell these adapter things, RJ45, and it breaks it out to the 4 pairs, which is going to come in pretty handy because we still have to use the CAN bus and break that out separately. If you're not familiar with Ethernet cabling or T568 standard, this is it. There's A and B. Don't worry about the A or B. Just, you can use either one. Just keep it consistent. The individual pairs, this is how it would look. For what we're doing, this really doesn't matter here. We're going to stick to what Sol-Ark did. They're just using this connector for convenience. So they're using the center pair for their CAN bus, and I think they're using 1 and 2 and 7 and 8 for their Modbus. And I think those, it doesn't matter which one you use. You just have to use 1 or 2 or 7 or 8. So it's just a matter of taking a short piece of patch cord Ethernet cable and plugging into the Sol-Ark and plugging into the breakout box and then breaking out what we need. And that's exactly what I did. I took a short piece that I had laying around, 3-footer. I went from here into the Sol-Ark, into my breakout. I did a quick little video of this with my phone. Pretty simple. And I fished through one of the conduits, some extra Cat 6 I had laying around. That's going to be the our lines going to the remote device. But for now, I'm just bringing it out outside of the unit for testing. Here's the 12 volts I'm going to steal from the unit and bring back. I picked the blue pair. And I'm going to bring that back to my test breakout that I'm going to have outside of the inverter. So I have this USB to RS-485 converter. Pretty straightforward. It's got a USB input. You got your RS-485 plus and minus AB. Ground is kind of optional, but doesn't hurt to have it. You can also do straight up TTL, RS-232, and of course it just connects to your normal USB port. Alright, so a little public domain research, and I found the Sol-Ark Modbus RTU protocol. So look at that, they kind of outline where to connect, although this is for the 8K. The 12K, which is slightly different, but it's a similar pinout. No CAN bus. And, oh yeah, there's the 15K right there. No, it's the 12K, sorry. But similar setup as the 15K. CAN in the center, RS-45 on the outer pairs. Ah, there's the baud rate and everything else. 9600. This is all boring Modbus framing stuff. Don't really need to know that if you have a driver. And, okay. So then they have their addresses for their registers. Okay. Yeah, there we go. This might work. Although I don't see a third PV1, I guess that's your photovoltaic array 1 and 2. There's no 3. I think the 12K only has 2. You can only handle 2 arrays, and the 15K handles 3. So let's assume that register 188 is PV3. We'll find it. We can figure it out later. Bit faults for their registers. So this is a good start. At least we kind of have an idea of, when we probe it with Modbus, what we're looking at. Okay, I think that's it for now. So the next thing I'm going to do is I'm going to set up this Modbus, and I have some third-party open source Modbus tools that we can connect to the inverter via this wave shear device, and we'll take a look at the registers and see if there's actual values in there, and take it from there. Or I might even code it up directly. I don't know yet. I think I have something that does that. But for now, everything looks like it's in place to do this, and I'll get back to you and look out for the next video. Thanks.